In this lesson, you are going to learn on the heating effect of an electric current passing through a conductor. You have to know that different electrical conductors do have resistance. Now, it is due to resistance offered by those conductors which make some of the electrical energy to be converted into heat energy. For example, when an electrical bulb lights on, you may find that after a given time it becomes hot. Why hot? It becomes hot because some amount of electrical energy has been converted into heat energy. Also, we are able to iron our clothes by using an electrical iron because an electrical iron is capable to convert the electrical energy into heat energy. So that's how you can find that it is very, very important to know the concept about heating effect of an electrical current because it is useful in our everyday life. Also, we do use heaters in our homes to heat water, to heat rooms. Those heaters are connected to the electrical circuit and you find that they become hot. After being hot, they are capable to heat maybe water or even our rooms when it is cold. So you may find that this knowledge about heating effect of an electric current is very, very important for you to know. Now, we have a problem here which is concerned with the heating effect of an electric current. It states that 20 amperes flow through a heater having a resistance of 3.5 ohm and the heat dissipated is used to heat 20 kilograms of water up to 80 degrees Celsius for 30 minutes per month. The question asked: 1. What is the initial temperature of water? 2. If 1 unit of electricity costs 560 shillings, how much money will be paid to an electrical company as the charge for electricity to be used in 15 years? Now, let us start the solution for this problem. Let us start with our first part. In the first part, we are asking you to calculate the initial temperature of water as the final one has been given is 80 degrees Celsius. You have to know that the amount of heat energy dissipated due to the electrical current flowing through a conductor, I mean a heater, is the amount of the heat energy that will be gained by water, which will raise the temperature of water from a certain value up to 80 degrees Celsius. Now, what is that initial temperature of water? You have to know that the amount of heat energy dissipated due to electric current is given as the product of current, time, and voltage. Also, we may express this voltage by using Ohm's law. As you know from Ohm's law, voltage is equal to current times resistance. Now, heat dissipated will be equal to the current times the time times the voltage, which is current times resistance. Now, heat dissipated, it becomes I square times resistance times time. I have expressed this into resistance, time, and current because in the data we have in our question here, we are given the resistance and not voltage. So that's why I have changed the formula. Instead of including voltage, I have changed it into the resistance. That's why you find the formula which is going to be used is the heat dissipated is equal to the square of the current times resistance times time. Also, this amount of heat is the same amount of heat energy which is going to be gained by water that will raise the temperature of water from a certain value up to 80 degrees Celsius. Now, the amount of heat energy absorbed or given out by substance is calculated by taking its mass, now it is mass of water, times the specific heat capacity of that substance, now it is specific capacity of water, times the change in temperature, Now, it will be equal to the mass of water, specific capacity of water, times temperature 2 minus temperature 1. As you know, the temperature 2 is the final temperature, which is 80 degrees Celsius, but temperature 1 is not known, which is the initial temperature. So as I have said that this amount of heat energy absorbed by water is from the electrical energy which was converted into heat energy, and its formula is equal to the product of the current times resistance times the time. Now these two values are equal, so I square times R times T will be equal to the mass of water, specific capacity of water, times change in temperature T2 minus T1. After that, we may substitute the values given. The current given, we are given that it is 20 ampere. So it is 20 ampere times 20 is it is I square times the resistance we are given 3.5 times the time which we are given here is 30 minutes per month. Every month that electricity is allowed to flow 30 minutes. So when we convert 30 minutes into seconds, it becomes 30 times 60 in order to make it in 2 seconds, as 1 minute is equal to 60 seconds. Now this value is equal to the mass of water, which is 20 kilogram, times specific heat capacity of water, which is 4,200, times change in temperature, which is final temperature minus initial temperature. Final temperature we are given 8 minus T1, which is not known. So we are looking for T1 as the initial temperature. Now let us see, when we look at this equation, 20 and 20 cancel out. Now we are remained with 20 times 3.5, 20 times 3.5 times 30 times 60 is equal to 4,200 times 8 minus T1. 8 minus T1. After that, let us divide by 4,200 both sides. On this side by 4,200, 4,200. Now we are remained with 8 minus T1 will be equal to, let us compute this value. We have 20 times 3.5 times 30 times 60 over 4,200. The answer which you get here is 30. Now the difference in temperature is 30. So to get T1, now 8 minus T1 is equal to 30. So T1 here will be equal to 8 minus 30, which will be equal to 50 degrees Celsius. Now the initial temperature of water will be equal to 50 degrees Celsius. This is the answer for the first part. Now let us see a second part, which is, if 1 unit of electricity costs 560 shillings, how much money will be paid to an electrical company as the charge for electricity to be used in 15 years? Let us see the solution for this. As we have said that the amount of heat energy dissipated when a given electric current is passing through a conductor is given as the product of current, time, and the voltage supplied. So we have said that the amount of heat energy dissipated is equal to ITV, meaning that current times time times the voltage supplied. But also I have told you that according to Ohm's law, V is equal to IR. So if V is equal to IR, V is equal to current times resistance. Now, when we substitute the value of V with IR, we get heat dissipated is equal to IT times V, which is IR. Now, this heat will be equal to I square resistance times the time. I have converted this, as I have told you before, in order to include resistance, as the data given, the given value is the resistance and not voltage. So now let us find out this amount of heat energy dissipated. The amount of this heat energy dissipated will be equal to the current square, which is 20 square times resistance, which is 3.5, times the time is 30 minutes, which is converting to seconds by multiplying with 60. Now, what do we get? Let us compute. 20 square is 400 times 3.5 times 30 times 60. We get 2,520,000 Joule. So this is the amount of heat energy dissipated when 20 amperes of electric current flow through a heater with the resistance of 3.5 in 30 minutes. Now, according to this question, we are required to change this amount of heat energy dissipated into the units of electricity. So, how do we change this value? You have to note that 1 unit of electricity is equal to 1 kilowatt-hour. And 1 kilowatt-hour is equal to 3,600,000 joules. So, 1 unit of electricity, 1 unit is equal to 1 kilowatt-hour and is equal to 3,600,000 joules. Now, how many kilowatt-hours are within 2,520,000 joules? Let us convert this. We have to take this obtained value over the amount of heat energy within 1 kilowatt-hour, which is 3,600,000 joules. So the total number of units which will be used per week will be equal to total number of units per week. Total number of units per week will be equal to total amount of heat energy dissipated, which is 2,520,000 joules of 3,600,000 joules. It will be equal to, when you divide, you get 0.7 units or kilowatt hours. But we are told that the charge for 1 unit is 560 shillings. Will be equal to 0.7, which is the number of units, times the cost per 1 unit, which is 560 shillings. When you take that value, you get 5 times 560, you get 392 shillings. You get 392 shillings. But we are told to calculate the charge of electricity that will be used for 15 years. Now, here we are required to know the number of months in 15 years. The number of months, total number of months in 15 years, total months in 15 years will be equal to 12 times 15, as 1 year has 12 months. So 12 times 15, 12 times 15, you get 108. You get 108. So This is the total number of months in 15 years. 108 months. So if per 1 month we pay, if per 1 month 392 shillings is paid, now how much money will be paid for 180 months? It is just to multiply. So total amount of money will be equal to 108 times 392. 180 times 392. When you multiply this, you get 7,560 shillings. 60 shillings. So the total amount of money, that will be paid for 15 years will be 70,560 shillings. 70,560 shillings. 560 shillings. This is all about our question. I hope you have seen the way we solve various problems concerned with the heating effect of an electric current. I thank you for your attention. Have a nice moment.